Refraction of light. The bending of light as it travels from one medium to another is known as refraction of light. Occurrence of refraction. Refraction occurs whenever a light ray encounters a boundary that separates two media. On entering an optically denser medium, the speed of light slows down, whereas on entering an optically rarer medium its speed increases. Let's understand, with the help of example, a slightly different and strange effect can be observed when you place a straight rod or a pencil under a glass table in such a manner that half of it lies outside. You will notice that the rod, pencil, appears slightly bent. This happens because when a ray of light moves from one medium to another, its speed changes. Speed of light in air is 3x10 ms and in glass is 1.8x 103 ms. Terms related to refraction. Incident ray, ray XO, which falls on the boundary AB, is called the incident ray. Refracted ray. When the ray XO enters the denser medium, it gets deviated from its original paths and bends. Thus the ray OI is called the refracted ray. Point of incidence. The point, O, on the boundary A, B, from where the incident ray enters the second medium, is called point of incident. Normal. The line N, P which is perpendicular to the boundary A, B, and is passing through the point of incidence O, is called normal. Angle of incidence. The angle X, O, N, which the incident ray makes with the normal, is called angle of incidence. Laws of refraction. The first law states that the incident ray, the normal, to the point of incidence, and the refracted ray, all lie in the same plane. The second law is based on the pair of media through which light suffers refraction. It states that the ratio of sine of angle of incidence to the sine of angle of refraction is always a constant, known as the refractive index of second medium with respect to first sin R equals constant. This law was given by Willebrord Snell, famously known as Snell's law. Refractive index. We know that light suffers refraction, that is it bends from its original path, because its speed changes when it enters the second medium. This change of speed is denoted by constant, called refractive index. Refractive index of a medium is the ratio of the speed of light in vacuum to the speed in that medium. Refractive index is represented by the symbol called mu. Mu equals speed of light in vacuum % speed of light in a medium. Thus, we can say that refractive index tells us how much the speed of light has slowed down in that medium with respect to vacuum. Hence, we conclude that more the speed of light is slowed down as it enters a medium, the greater will be the refractive index of that medium, and the larger will be the deviation of light from its original path. Test yourself. What is the speed of light in medium whose refractive index is 4/3? If the speed of light in air is 3x10 sms, solve this, and you will get the solution in second video. Unique properties of refraction. When a ray of light enters a denser medium, say from air to glass, it always bends towards the normal. So the angle of refraction is always less than the angle of incidence. A ray of light traveling from denser to rarer medium always bend away from the normal. In this case, the angle of refraction will be more than the angle of incidence. A ray of light traveling along the normal does not suffer any refraction. In this case, both the angle of incidence and the angle of refraction will be equal to 0.